our new learning target is to use our factor theorem to determine if x minus c is a factor, and then write our function in factored form. So we're going to take a look at our polynomial, make sure that this is all in descending order, but you can notice that we have x to the fourth and then our x squared. So we're actually missing our cubic. So we're going to add in a 0 there for a placeholder. So we want to see if 2 would be a factor of this polynomial, but really the factor will be x minus 2. Okay, so we're going to set up our synthetic division, putting our 2 outside, and then placing all the coefficients in front of our terms. So 1, we're going to put our 0 for our placeholder, -1, +2 in front of 2x, and our constant of 2. All right, and this remainder is going to tell us if we actually have a factor that factors into this or not. So synthetically divide, we're going to drop down our 1 first, and now we're going to multiply 2 times 1. We're going to add this column together to give us 2, multiply, add together, multiply, add together, multiply, and add together. So since our remainder is 18, that is not 0. So x minus 2 is not going to be a factor of this polynomial. It's not going to work. So now we're going to give b a try and see if -1 works. So -1 is going to go on the outside. Set this up. Same thing, all the coefficients in front of each term. And then there's going to be our remainder. So drop down our 1, multiply the numbers, add them together, multiply for a +1, and then 0 times -1 is 0, add together, and -1 times 2 is -2. Add together and we get 0. So this works. This is definitely a factor. And the factor is going to be x plus 1. So I can rewrite my function now, where x plus 1 is definitely a factor. And then the remaining is, since we divided this entire polynomial by an x, this term drops down to x cubed, x squared. Here's my x term and my constant. So since this is a 0, I don't have to replace it in here. If you want to, I'm okay with that, but you don't have to. So I'm left with an x cubed minus x squared plus 2. Okay, so next learning target is determine the maximum number of zeros and the potential zeros of the polynomial function. So to determine the max number of zeros, that is going to be looking at what's the highest degree. What is the degree of this function? Which, if you look, the exponent that's the highest is a 5. So that tells me that I have 5 possible zeros. So 0 again is an x value where y is 0 and you're hitting the x-axis. That will actually hit, cross, touch, or turn the axis on the x-axis. So now to find the potential zeros, that's our p's over our q's. So we want to take a look at our p-value, which is going to be our constant. So here's our p-value. Our q-value is going to be the coefficient in front of our leading coefficient. You want to look at the highest term and look at the coefficient in front. So our q is -6. So if we set this up, we want all of the factors of p divided by all of our factors of q. So again, all the factors of 1 is just plus or minus 1. All the factors of 6 is going to be plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. So to actually write down all the potentials, we want to divide all of these. So 1 divided by 1, we have plus or minus 1. 1 divided by 2 is plus or minus 1/2. 1 divided by 3 is a third. And 1 divided by 6 is plus or minus 6. So these are all the possibilities that could factor into this function. All right, moving on to our next learning target, we want to find the potential number of zeros and then sketch the graph. So same idea, we want to find our p's and q's and then determine what's going to divide into this function so we can break it up, factor it, and graph it. So our p-value is our 18, and our q-value is a 1. It's that leading coefficient. So let's find all the possibilities and break this up. All the factors of 18 are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and plus or minus 18. All over, it's going to bother me. Let me erase that. All right, all over the factors of 1, which is just plus or minus 1. So really, these are all of our possibilities. So I usually like to start a little bit smaller. So I'm going to just try 1 and see if that works. So 1's going to go on the outside, and now I'm going to make sure to put all of my coefficients in front of each term. We also want to make sure it's all in descending order, so 3, 2, 1, 0, we're good. So 1 is my coefficient, 2, negative 9, and 18. And here's where our remainder will end up. So drop down our 1. 1 times 1 is going to give us 1. All right, 1. Add those together for a 3. 1 times 3 is 3. Add together, negative 6. 1 times negative 6 is negative 6. That should be a negative 18. I'm glad I caught that right away. So that's going to be a negative 24, which is not 0. So that's telling me this is not a factor, it doesn't work. So taking a look at this, I'm thinking maybe 3 is going to work. So I'm going to give that a try. Set this up again. So I have 1, 2, negative 9, and negative 18. Make sure we keep all those signs in front. Drop down our 1. 3 times 1 is 3. Add together, get 5. 3 times 5 is 15. Add together, get 6. 3 times 6 is 18. Add together, and we get 0. So this is definitely working. All right, so I'm going to rewrite my function now. Let's change colors. So I have f of x equals, so if 3 worked, my actual factor would be x minus 3. And then I'm left over with these terms, which I started with a cubic. So since I divided once, I now have, this is my x squared term, x and my constant. So I'm left with x squared plus 5x plus 6. And I can factor this. So once again, I got to break that up. So I have x minus 3. And we need 2 factors of 6 that will add to 5. So that's going to be a positive 2 and a positive 3. All right. So then this is going to tell me that I have 3 different zeros. Every single degree is just a 1. There's just 1 of each term, and they're all different. And I should have a possible 3 zeros, so this is working out really well. So what I'm actually going to find out are now my intercepts. So if we set this equal to 0, we know exactly where we are on the x-axis. So x minus 3 is going to tell me that 3, 0 is an intercept. And since the degree is 1, which is odd, I'm going to be crossing at 3, 0. And then I have a negative 2, 0. And I'm also going to cross. And my last factor is x plus 3, so really negative 3, 0. Degree is 1, so I'm also going to cross there. So let's set up my graph. 1, 2, 3, 4. So I'm here. I'm crossing. 1, 2, 3, 4. So at negative 3 and negative 2, I'm crossing at both of those. So I want to determine my end behavior. And then again, it's going to be all about what the degree of our polynomial is. So since this is listed as terms here, we can look at the highest term, which is x cubed. So that's a degree of 3, which is odd. So I'm going to be going from down to up. So here's my endpoint. This one's going down. And over here, I'm going up. And I know that I have to cross, and cross through. All right, so made a little error here because I did not actually find my y-intercept, but I can do that quite quickly to find my y-intercept. Let's change colors. Okay, y-intercept. We're going to make sure that 0 is our x value, and we'll figure out what y is. So we have y. I'm going to use these factors down here. And I'm going to just plug in 0 for x's. So if I plug in a 0, I have 0 minus 3 times 0 plus 2 times 0 plus 3. Okay, so I have negative 3 times 2 times positive 3. So that's 6, 18. So a negative 18. So my intercept is actually 0, negative 18. So I'm going to just erase a little bit on my graph. Come on. All right, we'll fix this a little bit. So let's go down to negative 18. We'll just kind of pretend it's down here. Here's negative 18. So this is going to cross, come all the way down, hit, and go up and cross through. So that's more like it. I'm sorry for my little error there, but we got that fixed. Oh goodness. Now I just can't learn. There we go. Got to figure out how to use this Mimeo. All right. So I'm going to make another video for the last page.